Bob here from racecarbook.com, airdensityonline.com. We're going to set up a profile for a normally aspirated, fuel-injected drag race engine. This one happens to be a 540 cubic inch big block, which is pretty common in the sport. The first thing we're going to do is determine what baseline profile. We're going to try to select something that's close to what we have. Not knowing what we have, I'm going to go ahead and go over to Info. And coming down here, how to use sample baselines for normally aspirated engines. Okay, now this is a 540 cubic inch normally aspirated engine. These start out smaller and then they get bigger and bigger, and then the biggest one listed at the time of this recording was a 475. Okay, let's go to look at the 475 HP peak. Okay, let's see, that is normally aspirated 475 running methanol at HP horsepower peak with a high-speed bypass. I don't want to start out with a high-speed bypass. That's too risky. So I'm not sure I want to use that one. Let's go to the next one, which is normally aspirated 475 torque peak, TQ peak. That's my standard. That's again a normally aspirated engine size of 475 running methanol at torque peak without a high speed. Okay, that's the one I want. That's the closest that I have. So I'm going to go back to the baseline profile and I'm going to go ahead and select that. That's 475 torque peak. Okay, add baseline. Okay, now this is similar to what we have but not the same. So I'm going to make this a normally aspirated 540. Okay, I'm going to put 540 cubic inches in for the engine size. For torque peak, this is suggesting 100% volumetric efficiency, so I'm going to leave that the same. My fuel pump, I'm not sure which fuel pump I have, so I'm going to go ahead and go to my list of fuel pump sizes to see what fuel pump I have. Okay, going down the list, I have a Kinsler, an old KW 400 twin gear, which is 3.9 is my fuel pump rating. So that's what I need, is the 3.9 value from this list. So I put, okay, so there's my fuel pump entry. That was rated at 8,000 engine RPM, which is 4,000 pump RPM if it's 2 to 1. The number of cylinders is 8. This is a V8. The number of nozzles per cylinder is 1. The main bypass, I have no idea what I'm going to start out with, so I'm going to put 100 in there. So that seems to be a reasonable starting value. I'm not putting a high speed in at this point. I don't have a second high speed. I don't know what the pressure is. Target RPM is 5,000. I'm going to leave that there. That's the stall speed of my torque converter, and that's where I want that high speed to come open. Okay, I do not have any nitro in the engine, so I'm not selecting that. And then the weather in the area that I'm at is typically 80 degrees, 40% humidity, and 29.2. This would be typical of many of the Midwest racing facilities, about 1,000-foot altitude, somewhere in that ballpark. Since we have the uncorrected barometer, we do not need the altitude. Okay, going up here, we don't know what nozzles we have, so we're going to leave the 34s in there, and I'm going to go ahead and create this so we have something to work with. So go ahead and create baseline profile. Okay, now this is showing an air-fuel ratio of 7 to 1. That is way too lean from our database. So what I've got to do now is develop this. I'm going to jump right to jetting from pressure because I don't know what main bypass or nozzles. Okay, I've got my combination in here, and it's pulled all the data out of the baseline. Unfortunately, some of the numbers are wrong. Well, the engine size is correct. We're working around the torque peak, so the volumetric efficiency is correct, and the fuel pump is the same. There's no nitro. We're leaving our tuning RPM, that's our fuel pump rating, at 8,000. We're leaving our target at 5,000. I'm going to change my air-to-fuel ratio to 4.9. That's a typical launch value. Okay? Now, it's pulling the pressure value out of the baseline, but that's wrong because we're going to be making a determination, and I want about 140 psi of a fuel pressure. Okay, I have to re-enter my weather. That was 80 degrees, 40% humidity, and 29.2 was the typical uncorrected barometer. We're going to be computing nozzles, so this value, the number that is in this field, those will all be ignored. Go ahead and get jetting. So jetting from pressure has computed that I need some O32 nozzles and an O59 main bypass. I write down O32 for my nozzle size and 59 for my main bypass. Now I go back to the baseline profile and I put in $59 thousandths for the main, and then I put in 32 thousandths for the nozzles. Assuming the same weather and the same RPMs, go ahead and set up this as the baseline. That's close to my 4.9 air-to-fuel ratio as I was selecting. Okay. The next step would be to set up the high speed. One of the ways to do that is to go to the new baseline profile and copy baseline 1. Now that sets up a duplicate, but this is going to be horsepower peak, so I'm going to change this torque to HP. But I don't have my high-speed data yet, so I'm going to leave this blank for now, and I'm going to go to create baseline, everything else being the same. Okay, again, it's the same air-to-fuel ratio, and it's all the other data. Now, actually, at the high speed, when the engine revs up at the high end, the volumetric efficiency drops. So I'm going back into the edit this baseline, and I'm going to drop my volumetric efficiency to 80%. This would be typical of an engine up there around the 8,000 RPM range or on the way up. Edit this baseline. And what this shows is a very fat 3.89 air-to-fuel ratio, which would be the enrichment that would occur without a high-speed bypass. So what I want to do now is determine a high speed to lean that down to something a little over 5:1. To do that, I'm going to go to the air-fuel ratio calculator. I've got to select that second one, the horsepower peak, use that. Okay, so now, again, the same thing came up except that it's at 80%. Okay, all other numbers are the same. What I'm going to do now is put in a high speed. Now, one of our jetting books suggests a good place to start with a high speed size is something similar to the size of the nozzles, maybe a little bit bigger. So let's start out with a 35. So let's put a 35 in there. Go ahead and get air-to-fuel ratio. Now that's showing a 430 air-to-fuel ratio. That's still a little on the rich side. So let's go ahead and change that. Let's go up to 45. If you were testing a new combination, this would again be a good typical way to do it. Start out with one that's a little on the small side and start bringing it up until you're looking for spark plug color. Okay, go ahead and get air-to-fuel ratio. Okay, again, it's coming up on us. That's starting to get in the ballpark, but that's still on the rich side. So let's go back down here and let's go up to the next side. Let's go to, say, 55. Okay, get air-to-fuel ratio. 490. Okay, that's back close to where we launched at, but that's a little on the rich side at the high end, so I want to go a little leaner than that. So I'm going to go down here and I'm going to go, let's say, go 60. Get air-to-fuel ratio. Okay, 509. All right, I'm a little over 5:1. That's pretty good. That would be a pretty reasonable combination. So coming back here, what size high speed am I in? A 60 thousandths. So I'm going to go back to my baseline profiles. I'm going to select the HP profile. I'm going to put a 60 in there. And lo and behold, I've got my launch air-to-fuel ratio with no high speed and my high-end air-to-fuel ratio with a high speed. Thank you very much for your time.